So today's topic I have is solving the complexity of data science to production through Bodhi, which is our internal accelerator that we have been working. So since morning, we have heard a lot of great things about data science, AI, and machine learning, and all the cool stuff. So let's talk about what exactly are the complexities and the challenge that we're talking about here, and how Bodhi can actually eliminate or try to tackle some of these challenges. But before we get there, right, why we are talking about this? The reason we are talking about this because we are generating data like never before across devices, purchases, media habits, applications, even our cars are now generating data. That means that's where AI becomes a very crucial factor to use all of these data to generate right insights. In fact, AI is also being termed as the software engine powering the Industrial Revolution 4.0. So in fact, there are a lot of investment being made in this field, right? If you look into the Gartner's report, roughly around $3.9 trillion value would be created by the next year, right, by using AI and ML. And roughly $77 billion would be spent into building these AI systems. But if you look into how many all of these AI systems and AI ML systems that they're building, they ever actually see a light of day. And here's bad news for you. Roughly around 87% of AI and ML projects and the data science projects never make it to production, right? While we all can debate on an actual number, be it 80% or 90% or 70%, but give or take, majority of these projects never go into production. That means is all of the investment that we are making, we are not realizing the full value. So why it is such a case? Why we don't see more and more such projects going into production? Well, let's look into this slide. Here it is just talking about what happens when you shift from an initial POC in the research and evaluation phase to building a full grade production system. In the research and evaluation phase, you might be taking data, maybe you already have data, maybe CSV files and whatnot. You use some analysis, you do use your machine to do some small scale training, and then you come up with your model performance. Let's say you're happy that, you know what, I have a model which will give you 80% accuracy or 95% accuracy. But as you move from a POC to a production, you need to think through that you need to maintain multiple kinds of data sources. You might have real-time systems coming in, you might have batch data, and then you have to even prepare the data at scale. And then you need to use more than one machines or maybe hardware accelerators combined to do a large scale training. And then once you got a model, let's say that you got one model, and then eventually over the time, you might have multiple model versions, and you need to use all of these models in the near real time for a lot of use cases. And you need to also maintain what is the model performances across performance core functional metrics like model accuracies and whatnot, and non-functional requirements such as latencies and throughputs. So all in all, if you see that some of the key challenges are how to deal with scale. How do we even build very complex workflows that we have right now here on the screen? And how do we even enable collaboration among the team members, which are coming from the multiple kind of skill set, maybe data engineers, data scientists, ML engineers, maybe DevOps folks, and how you even track all of the experimentation that you have been doing and monitor the entire system performance. So in fact, if you look into model development, is just one part of the puzzle. And if you have, let's say, a simple or maybe a medium complex use case, maybe with a team of 2 or 3 data scientists and analysts, you might be able to solve that problem maybe within weeks, and you are able to develop and evaluate your model locally. But it can take months to actually take some of these models into production, and might require a huge team of developers, data scientists, engineers, and DevOps, because you need to take the solution that you have to package it, you have to run it at scale, you have to tune it at scale, and then apply all of the instrumentation around it, be it monitoring, logging, versioning, and security, and then automate the entire process, be it the CI/CD. You need to do maybe A/B testing and multivariate testing or try out different releases. So all of this can take, in that 9 years, can take substantial effort. So let's see that we have a use case. Let's see, we have 3 SWAT team. We have Alice, Bob, and Priya. They've been targeted to build the next gen recommendation system for a large scale enterprise that can be integrated with their product pipeline for real-time recommendations. Now here we am taking a recommendation engine, a problem statement, but you can pick any other use case. Even in the recommendation, it could be product recommendation, it could be service recommendation, it could be cross-sell, upsell. There's so many things you can do. But you see the words that have been highlighted in blue. Next gen, because let's say that people, they want to try out different kinds of algorithm, means there will be a lot of experimentation that will be involved. Large scale, because let's say this particular enterprise, they have a huge consumer base and they need to try out everything at scale. So maybe with the data that they want to use to train, they need to train at scale. And then everything has to be integrated, means that you have to expose your entire model into some kind of format, maybe a microservice or others, that can be integrated with a wider ecosystem. And then you need a real-time recommendation, means all of the non-functional requirements becomes really critical, be it latency and throughput. And we have the team members with a different kind of skill sets. We have data scientists, maybe more in machine learning, less on engineering, and you might have ML engineers who might somewhat of know about machine learning, but more on engineering. So let's go through this journey by Alice, Bob, and Priya, and what they go through this entire development to production journey, and where Bodhi fits in, and how it can mitigate some of these challenges along the way. So typical journey might look like that the data scientists, they're getting into their initial exploration. They need some environment to try out different algorithms. They also need to track their experimentation, what they have been doing. And then once they know that this is the approach, this is good enough, they need to train everything at scale. They might need to require distributed jobs across multiple machines, might require multiple GPUs. And then once they have the model ready, they need to serve that model, means expose that as some kind of an API, and then provide that to run some kind of a test. Even they need to version their multiple versions of the model. And once everything is running in production, they also need to monitor for functional KPIs, for example, when they need to retrain the model again, or what is the non-functional requirements, and if required, auto scaling and even rollbacks. And then automation for doing this over and over, building this entire reproducible and robust fault-tolerant pipelines and reusability of features across multiple use cases. So let's start from this first step, which is exploration and experimentation. So we have our data scientists. What they need is, first of all, they need a secured environment so that they can have all of their dependencies. For example, they're working on recommendation engine. So let's say they might be using some of the cutting edge TensorFlow or PyTorch or Chainer, or maybe some of the other kind of open source frameworks to build their next version of their recommendation system. And they need that environment so that they can work on it. And then they also might need some hardware accelerators, such as the GPUs or TPUs, for faster experimentation. And they also need to collaborate among themselves to see that, hey, you know what, this is the approach I'm working on. Why don't you take a look, or maybe review what is the current work that has been done so far. And then last but not the least, they also need to track all of their experimentation. They need to track their model. They need to track all of the data and the slices that they might have come up over the time to see that what data worked, what model worked, so that they might have a moment of epiphany saying that, hey, you know what, 2 weeks back, I tried out this algorithm A with certain kind of hyperparameters that led to 5% jump into model accuracy. So all of these is needed. Now let's see that where Bodhi can help into solving some of these challenges. So what exactly is Bodhi? Bodhi essentially is an accelerator that we're working on, which is built on open source stack. And everything we are here is being deployed through infra as code, through Terraform, which sets up entire thing. And underlying layer essentially is Kubernetes. And since morning, we talked about a lot of benefits about Kubernetes, but essentially this allows cross-platform portability. And we'll talk about in detail that all of the auto scaling and other things is baked in. And then we are also using other components. For example, Istio is essentially being used as a service mesh to tie out multiple components. And then you are using Dex essentially for providing that authorization and the security layer. So for example, one of the key component that we have here is the authentication component, which is through Dex and Istio, which uses your Istio gateway along with your Envoy running in the sidecar containers that can provide the authentication layer. And then you can also attach some of the, let's say, cloud specific solutions like Cloud Armor. If you want to have additional, let's say, crowd side XSS attack or DDoS attack, you want to take care. And then this also provides the identity mechanism. So currently, for example, the current Bodhi platform that is currently running, we have integrated that with our own PS login, right, which is our SSO identity provider. And then you also have all of the role-based access control and the profile access policies that can help to create user namespaces. That means is both Alice and Bob have their own profiles created, and we can provide all of the resources that they need to solve their problem. And then through these namespaces, we'll provide the notebook servers, which essentially is the environment in which they can run their experimentations. And these notebooks can be spun as quickly in milliseconds or seconds by using a lot of pre-built images that we are working on. So we have pre-built images for working on recommendation engine problems. We have for NLP problems, for computer vision problems, and much more. And then we can also attach on-the-fly hardware accelerators such as GPUs and TPUs to these environments so that they can expedite the experimentation process. And everything is backed by low latency storage, and that is coming from your NFS layers. And on top of NFS, we're using the Dynamics NFS provisioners that can create the persistent volumes and persistent volume claims. These claims are bounded to these notebook servers, which essentially provides a mechanism to share the work as well as the environment. And then you also have another layer, which is a metadata store, which is running as a stateful application inside the Kubernetes, which can provide mechanisms to track all of the different metadata associated with the experimentations. So all in all, you have a shared workspaces that Alice and Bob share, and they can try out different experimentations and track their experimentation. And here is just a few snapshot of the platform side of it. So you have the notebook server environment, you can attach and configure different resources. You can in fact build the very sophisticated pipeline directly from the notebook. You can share the notebook servers among your team, and you can collaborate with them. So let's assume that probably you have done the exploration and Alice and Bob have come up with the best solution that is fine for their work. And they need to now go to the next phase, which is train and tune at large scale. So obviously they need a mechanism to distribute the training job to deal with the large scale of the data. They need to track and analyze the hyperparameter tuning experiments at scale. And let me tell you, if you have ever worked on any kind of a machine learning and AI problem, hyperparameter tuning is a time-consuming process. And sometimes it can take days or sometimes even months to try out different combinations. And last thing is that once they have the different models, they would like to persist all of these models for serving purpose. So let's see that what are the different components inside Bodhi that can help you expedite this process. So inside Bodhi, we have different kinds of operators, which essentially are nothing but the CRDs, which is your custom resource definitions, which are running as operators inside the Kubernetes environment. And we have multiple distributed operators to deal with TensorFlow, if you're dealing with PyTorch, if you're dealing with MXNet or Chainer and whatnot. And then there are multiple hyperparameter tuning operators, which allow the hyperparameter tuning process. And everything is backed through configuration. So you can configure how many workers, what are the different strategies that you want. You want mirrored strategies, you want multi-worker mirrored strategies, you want GPU strategies. You can select your hardware accelerators. For hyperparameter tuning, you can select what are the different hyperparameters you want to tweak. And then you can simply select what kind of a strategy that you would like to adopt. From the standard grid and random search, you can go to very sophisticated Bayesian and hyperband kind of strategies as well. And all of this, as you configure all of these operators, all of the provisions will happen automatically for you in terms of nodes, pods, and resources. And then all of the experimentation will also be tracked. Just to give you an example, so this is just a very simple spec where you can actually configure what is your need for hyperparameter tuning. So here we are saying, hey, you know what, take my data and try to maximize the validation accuracy and try to reach 90% accuracy, and also additionally measure the loss and accuracy on the training data. And I want to use Bayesian optimization. And it is as easy as defining the configuration, and that will spin up multiple parallel experimentations. And on the right-hand side, what you see are all of those different experimentations. Every line on the horizontal axis, it represents one single experimentation, and you can filter all of these experimentation across the different hyperparameters. So let's say that, okay, now you have trained the model and we have the right model with us. The next step is, how do you even serve the model? How do you expose that as API, something that is low latency? And how do you monitor? So first of all, they need to expose this entire APIs through, which obviously need to be low latency, but also needs to have features like auto scaling. And they need to also try out different combinations of the models to test out. Maybe they have come up with a newer version of the recommendation engine that maybe they claim that it will lift the overall conversion rate, right? So they need to test it out in the wild. They might have to do canary releases by incrementally shifting the incoming traffic. Or maybe they also need to track the functional metrics such as model performances and the non-functional metrics like latency and throughput. So inside both these, so the component that we are using here essentially is built on top of Knative, which provides eventing. And then there is an abstraction layer is being used, which is called cave serving, which essentially provides, so let's say that how it works out. So let's say that you have your incoming data, the browsing as the people are browsing through their systems, you're generating that event and pushing into the Kafka. In fact, we are also deploying Kafka inside Kubernetes as a stateful application, but it could sit outside as well. And then the data is coming in and it generates your Knative eventing, and that is connected to send to a data for prediction, right? It can take the transformation, it can perform all of the required transformation and feed it to the predictor to make the final prediction and generate the final recommendation. And all in all of these platforms, the platform, it provides different kinds of features. One of the feature obviously is the low latency serving. So it provides the different kinds of interfaces, be it the gRPC interface or maybe the REST interface. And since it is using Knative and Istio, it will help to auto scale all accordingly, right? So you can go scale to 0 or to whatever if you want. And everything is happening as what we call as a serverless inferencing, right? So essentially, you don't have to bother about all of those things under the hood. There are abstraction layer which will allow you to perform all of these activities. In fact, if you need a GPU for inference, for some of the cases where, let's say, especially for computer vision problems, you can actually leverage GPUs by the way. And then integrating that with the different kind of strategies. So you have the A/B test, you can try out candid releases and the blue-green releases by trying out different models along the way. And on the functional metrics, we have Elabai as essentially again open source framework that is being integrated, which allows us to provide the model performance detection. Essentially, it can detect the concept drift, which essentially is if over the time, if consumer behavior have changed, you need to know when you need to retrain your model. And that's where the concept drift detection becomes a really key part. And we have seen this especially in the COVID world, because obviously the consumer pattern have changed a lot. But it also provides some of the other functionalities, such as the bias detection, even anomaly detection, as well as model explanation, especially for use cases in the financial services industries where you need to also explain why you're getting certain predictions. So it has a lot of explainers already baked in. And then all of the non-functional requirements, we have frameworks for monitoring, logging, and tracing. So all of the fancy names, be it Grafana, Prometheus, or Eager, or even the entire ELK stack is already baked in. So this is just a quick summary. So this is one of the APIs which is currently running inside the Bodhi platform for one of the computer vision API. And you can see that as you scale it up and as you have more requests, based on the different target QPS or the concurrency, it can auto scale and create new parts. So now let's say that, okay, you have model, everything is running in production, but you want to do it more often. And then that's where the ML engineer is being tasked to create a workflow which is automated in nature. So maybe you want to retrain your model maybe every week or maybe every single day or maybe every single hour. And then you might need the entire CI/CD pipeline, and you might have some control gates such as human in the loop. So for example, hey, you know what, I have created a new model. As I check in my code, I need to know that whether this model is good enough or not to push into the production. You also want to try out different kind of a bias detection. So we are not talking about ethical AI. So we have also baked in a lot of ethical AI components by the way in the platform. And then you might also have requirement around publishing these features. So because you're not building only one use case, you might be working on multiple use cases, let's say different kinds of recommendation engine, right? So you also want to reuse all of these features across the different use cases, maybe across teams. So let's see that probably what are the components kicks in here from the Bodhi platform perspective that can help in. So on the workflow, obviously you have the entire DSL, which essentially is a domain specific language, which can allow you to create very sophisticated pipeline and then allows different operators so that you can have different kinds of DAGs. And then you have different configuration parameters based on your requirement. And then you can use all of these. So currently we are using Argo under the hood, which Argo is used as a CI/CD and the pipeline and scheduling layer. And then everything is again being tracked through underlying meta layer, a metadata layer, which can track all of these experimentation. Just to give you a screenshot, so here you can see, for example, on the left-hand side, what you see here, you can try out different pipelines, you can run it at different instances, you can schedule it, and all of the fault resiliency and everything is already baked in because everything is running as a pod and it can again restore if it gets into a failure mode. So, and on the right-hand side, you see you can create very complicated pipelines. You can even see some of the visualizations around your model metrics. You can compare multiple experimentations. And this is just a one flow, right, which is for the CI/CD and probably GitOps kind of a flow, where let's say based on the Git check-ins, you want to run your model performances, you can do all sorts of things, right? But again, you can integrate it with any other kind of a CI/CD mechanism. You can integrate with GitHub Actions or maybe Travis or maybe even Jenkins. Now, let's say that probably the team has worked on this use case and everything was working fine, but somebody said, hey, so you know what, let's build another kind of recommendation, maybe for a different kind of a use case, maybe a homepage recommendation, or maybe a product recommendation. There's a cross-sell recommendation. Now, one thing that might happen is the different teams, right, working on a different kind of a use case, they create their own features, but you don't want that. You want mechanism there, the different team members and the different use cases can share the features that they are creating, because every feature takes a lot of effort, right? And then you want to make sure that there is a consistency being maintained, what you are using during the training time, and then what you're using on the serving side. And then you essentially you want to decouple your feature engineering and the modeling activity. So remember in the morning session, what Rakesh was talking about, some of the principles of the dry, do not repeat yourself, and the separation of concerns. So essentially all of those becomes a need, even in the machine learning and data science projects. And then you might need all of these features in the real time. And then you might need to support multiple kinds of frameworks, because you don't want to stick to one kind of machine learning framework. You don't want to use only TensorFlow or only PyTorch or only Chainer or something else. So that's where the feature store comes in, which is again a part of the Bodhi platform. So what feature essentially store provides is a public pub/sub mechanism where data scientists and ML engineers, they can publish the features to the feature store, and that can internally run some of the Beam pipeline. And you can use it for a training purpose by connecting to the historical store. And that could be different kind of data warehouses. It could be BigQuery or others. And or you want to use it for during the serving side, and it can come, the data can come from your online store. For example, it could be Redis, right? And then obviously different use cases can subscribe to these features. So while we talked about all of the different components, we actually tested out this entire approach, right? And this is just an implementation in one of the large retail implementation. And what we realized that even with the very smaller subset of the components that we used here, that was able to reduce the ML onboarding use cases time by almost by 150%. And the algorithm, obviously the recommendation algorithm, also lifted the revenue by 9% or so in a very short interval of time. So while we talked about all of the different components, essentially Bodhi is nothing but amalgamation of all of the different components inside a single box, right? And that's what we call as an accelerated data science or accelerated ML. What you see on the left is essentially is all your infrastructure on the bottom, leveraging Kubernetes in Istio and the low latency storages, which can run across multiple clouds. That means that the entire system is cloud agnostic, but you can also run maybe an on-prem if required. And then all of you have all of these scaffolding layers, which you can use. You can think them as Lego blocks, right? And based on the use case that you have, you can pick and choose and then combine them. And what you see on the right-hand side, what we have seen today is just one example, maybe using it for building a recommendation engine. But essentially, you can use these for solving any kind of a use case, be it forecasting, computer vision, NLP, anomaly detection, even optimization. This is just to give, so what we have done is we have created multiple scenarios. This is one of the scenarios how we are using the different Lego blocks, what we have in Bodhi to solve a real-time image stream classification, right? Where we are using Minio. Again, Minio is already is a part of the Bodhi platform, which is Kubernetes-based low latency object storage. And where you simply upload your data, the streaming images to Minio, and that is being connected to the Kafka layer. And essentially all of the predictions are happening on the fly and you get the outcome. Or it should be real-time Twitter sentiment analysis and reporting. So you have, again, your Twitter stream connected to the Kafka stream. You're doing the prediction, and then we're saving it to some kind of a DB, maybe a MySQL. And we are also have added a superset, which is a reporting layer, BI and reporting layer inside the Bodhi. But like I mentioned, is all of different components, the Lego blocks, you can actually swap, right? You can actually move out any component outside the platform and use any cloud-specific services. For example, you might have Kafka sitting outside. You might have reporting. You might be using, let's say, BigQuery. So let's say Tableau or any of the Power BI could be, right? Or you might have your DB even sitting outside. Or you want to use any specific cloud-specific ML services, for example, Azure ML or SageMaker in AWS, right? So all of those are possible. So all in all, but if we just take a quick recap, right? We have these three folks, and we talked about the entire 9 yards. And they need to know, multiple things. And we talked about so many technologies and components. And in fact, it can be overwhelming, right? So it can be really daunting if you're expecting a data scientist to know everything, right? So what do you do, right? And that's where Bodhi comes in, right? Bodhi essentially provides a mechanism of providing an abstraction which can allow a low bar, making sure that it is easy for new folks to get started, right? They don't get just bombarded with all of these technologies. Rather, they have the abstraction layer and they directly use those abstraction. And under the hood, all of those components will be used. But it also allows the high ceiling. That means is allowing those experts to do very complex customizations based on their project requirement or let's say client requirement. And making sure that the key tenets here is everything is composable, and then everything is scalable and everything is portable. So here's a summary. What exactly is Bodhi? Bodhi is a cloud agnostic, enterprise ready, scalable AI ML platform that can cover end-to-end workflow from development to production. It is built for enterprise need. That means is all of the required components that is needed in the enterprise system is baked in, and everything is baked in, put it in the open source stack. And like I mentioned, is everything is also Lego blocks. You can actually swap in if required for any specific cloud specific solutions if you want it. And so all in all, the value proposition is bringing the collaboration, bringing the best of the engineering principles and the scenarios. So we have created a bunch of scenarios, hundreds of scenarios and notebooks for your specific use case. But it's not like that. We are also using the thing that we are probably putting it out, right? We are using it internally to our data science teams for rapid prototyping. In fact, all of our internship projects, we used Bodhi for that. We are using it, the same environment for DS hiring, where people are trying out different coding tests. We are also using it for building solution in the box. And in fact, hopefully in the next event, we'll have another session on the solution in the box. And first solution in the box that we're working on is Bodhi Forecast, which essentially is creating a SaaS kind of a solution, again, by leveraging all of the Lego blocks that is available through Bodhi. And then it is also powering some of the other accelerators that we are working on. So you might have heard of CAS, which is our NLP-based knowledge system service. And we have the smart retail and the smart vision that we are working on. And everything is being powered through Bodhi. So what next for you, right? If you want to know more about Bodhi, you can go to psbodhi.ai, know more about it. There is an entire demo that we took in the Global Spotlight session that will take through the entire journey. We have taken an entire use case and gone through the entire process. So here's a link for that. In fact, if you go to, there is a link that will redirect you to SSO login, but you might, if you don't have access, you might not be able to access it. So you need to raise an access request, and here is the link. Here's a bit.ly link for that. Reach out to core team, to Sudan, me, Anirudh, Monica, and Anu, if you want. So last, we started with this line, right? Which is 87% of AI and ML projects never make it to production. Let's use some of these principles that we talked about throughout the day to remove the never. And with that, I thank you all.
So much for that very interesting talk, Abhishek. I see a few questions. Should I throw them across to you, the
Sure.
team? Have you, where all do you see this tool already deployed for clients? Do you have some use cases or some samples you can share?
Yeah. So one of the things that we talked about is, in fact, there was a slide, right? So we used a similar architecture, essentially almost the same architecture for one of the clients, one of the large retailer, right? And we can share more details after the call. We are using it for some of the other retail conversations as well, by the way, for solving some of the POCs and how to take it to the production, right? And as we are speaking, we are in fact pitching for multiple other projects, right? So, and we also towards the end, we talked about that how we are using it internally, right? So there are multiple usage of this.
Can it be open source within PS?
Yeah, so it is already there in the PS code, by the way. So obviously you can reach out to us, right? And we can share whatever that we can.
Sure. I see a question not directly related to Bodhi, but I'll still send it your way. Which are the areas where one can deploy AI ML, like in predictive analysis? Is it possible to use Bodhi or any other areas?
Right. So like I mentioned, I think we had a slide where we talked about all of the different components, right? So Bodhi has multiple components for the development purpose, all of the POC and expediting that process to the deployment. Now, there might be certain scenarios and use cases where the end outcome might be a presentation, right? We are using some data, running some algorithms, extracting some insights, and passing on the information in the form of, let's say, slides or presentation. But there might be most of the use cases, at least in the real world production, where it need to go to the entire 9 yard, right? So it has support for both of these scenarios, right? So you can do faster experimentation, but you can also take everything into production, in fact, post-production. So there's a lot of, you have heard of the term MLOps, right? So we have seen SecOps, we have DevOps, now we have MLOps, right? So essentially this enables the entire MLOps.
Interesting. And do you see any kind of resistance from clients? It's deployed on cloud for clients, and can it be deployed on their premise? And would clients agree to move data outside where the tool is actually deployed?
Right. So how we see here this entire platform being deployed maybe in the client environment only, right? In most of the scenarios, right? And like I mentioned, this is the platform is completely cloud agnostic. So that means is whatever the cloud they might be using, we already have a platform running in GCP, we already have it running in AWS, we already have running in Azure. Yet to test some of the things on-prem, by the way, right? But that's also a possibility because underlying everything is running on Kubernetes, right? That gives all of those flexibilities. In fact, there is lately what we are also observing, especially for some of the solution in the box, right? That we'll probably share more details down the line. A lot of clients are saying that, okay, we don't want to bother about all of the infra and everything is happening. And then we just want to do like pay-per-use, just like what some of the other services being offered by cloud to other cloud providers. In fact, we are looking into that model, right? And as we are speaking, we are talking to some of the other cloud providers as well to see what is our go-to-market proposition.
What would be some of the KPIs that we share with clients while pitching in for Bodhi?
So again, so for example, we talked about the KPIs, and the KPIs, we talked about both core KPIs from the model perspective, but as well as non-functional requirements. So any use cases which we are need to use in a real time or near real time, it has to have its own SLAs, right? In terms of the latencies and the availabilities and whatnot. And then, or maybe if we have a pipeline which runs through a processing layer, so how faster we are able to process. Obviously, there will be a lot of those kind of KPIs. But obviously, through the modeling perspective, there's a lot of KPIs. At least a lot of clients are expecting, right? Hey, you know what? I want my forecasting system to be at least 70% accurate, right? Not always you will hit that because there are a lot of challenges in terms of what is the right data you have or not, or the entire ML and AI is also an iterative process. And that makes it really critical, right? And that's what is challenging from a traditional software development projects versus an AI ML project. And the reason what you see on the screen that 87% of AI ML projects never make it to production is not that nobody wants, everybody wants it, right? But there are a lot of nuances and challenges involved into that process that makes it tricky, right? That makes it harder. And we are still progressing, right? Going through this journey. And a lot of organizations are also going along the way, right? In fact, I am part of the global community for MLOps, right? With a few folks in Google and Microsoft. And as we are talking, we're also devising what are the strategies that how we should take this entire field, right? So that organizations probably should reap the more benefit, right? We talked about a slide that so much of benefit, so much potential that AI and ML have, but how do we maximize it? And that's the key. And that's where I think the levers for all of us is to reach out to clients, or maybe if you see opportunities where we are making investment, but need to make sure that it is reaching to the right level.
True. I think the usability is paramount. I need to take those conversation backs as well. I'll throw one last one to you, sure. Abhishek. Do you, and I'll kind of combine two in this one, do you see partnerships in pipeline with major cloud providers on this one? And AI ML being striking features, which all areas can it come in handy?
Yeah. So the first one, like I mentioned, is as we are speaking, we are already doing it. I don't want to probably get into the details. Reach out to us or to Sudan, right? We are already talking to some of the cloud vendors, right? And finding out probably what is our go-to-market strategies and how do we want to position it. But how for our clients, at least so far in the proposition that we're getting into is how this platform can accelerate the process, right? And that's where the idea is. So how do we reduce the timeline, which is going in a month to potentially in weeks? So I think that is the biggest factor for us, right? Now, second thing is in terms of the kinds of use cases, we had an entire slide. You can do anything, right? This is just all of your Lego blocks. And as a kid, you use these blocks to make houses, you use it to make rockets. It's up to you. It's completely limited by your own creativity.
And I think this was very helpful. I see a few more questions popping in. My request to all the people who are asking, connect with Abhishek, reach out to Sudan as well. Personally, I know both of them. They're very, very helpful and always happy to get into a conversation. Thank you so much, Abhishek. Wonderful conversation. I truly saw the engineering of the next on this one.
Yeah, so if we don't have any other question, maybe it's time for me to go back to Matrix. What is that?
Thank you so much. This was helpful.